Welcome to Dinosaur Electronics. The purpose of this video is to answer the majority of questions you might have for the operation of our testers. We make a fairly broad line of testers. Those that are designed for testing igniter boards, whether they're 12-volt DC igniter boards or 24-volt AC park models. We make a tester for doing all the old AES Dometic refrigerator boards, and we make a couple of exercisers for testing and exercising the Dometic and the older Norcold refrigerators. The first category that we're going to cover is all of our testers associated with 12-volt DC igniter boards. In order to test an igniter board properly, you should really understand what it is the igniter board is supposed to be doing. So let's take a look at the functions of a standard 12-volt DC igniter board. Basic ignition control modules, as used in RVs, must do the following. First, they have to receive appropriate power, usually 12 volts DC or 24 volts AC, from some temperature sensing and associated safety circuitry, namely thermostats, sail switches, high limit switches, and so forth. Second, after an appropriate delay, usually from 2 to 20 seconds, begin the ignition process and open the gas valve. In the early days, the ignition gas valve cycle occurred only once. Somewhere around the late 80s or early 90s, boards were developed which would go through the delay ignition cycle 3 times and are hence known as 3-try boards. Third, once the gas is lit, the board has to sense the existence of the flame, sometimes called proofing the flame, in order to keep the gas valve open and continue to produce heat. Fourth, if for any reason a flame is not sensed, even though one may exist, the board must remove power from the gas valve and allow it to close, which it does so under spring pressure. Fifth, 3 different flame sense or flame proofing terms are in common use. A, remote sensing. The signal applied to the sense electrode comes from one of the finger contacts on the edge of the board, usually the one between the valve and ground fingers, and may be identified by an S or an S1 or sense, etc. B, external sense. The signal applied to the sense electrode comes from a separate wire that dangles out of the igniter box, but goes to the same electrode as the remote sense signal. Finally, C, local sense. The sense signal is applied to the spark electrode through the spark wire, but time-wise it occurs between the spark pulses. Local sense systems are by far the most common being produced today. Now, so much for basic igniter board requirements. But wait, that's not all. For no additional cost, but perhaps a little patience, here is some more about igniter boards. The check light, frequently used in water heater and refrigerator controls, comes from the igniter board. The NC terminal on the edge of the board comes from the normally closed contact of the relay, hence the NC description. Usually, when igniter boards are used in water heaters and refrigerators, the delay time between applied power and activation of the gas valve is from 2 to 5 seconds. During that time, the NC terminal of the board activates the check light on the control panel. The check light goes off when the relay activates the gas valve and stays off if the gas is lit and a flame is sensed. However, if a flame is not sensed, the valve is deactivated and the check light is reactivated. Finally, the latest in igniter boards have some new features. In 1994, Dinosaur pioneered a fan control board for use in furnaces. Recently, approximately 3 years ago, both Suburban and Atwood Hydroflame have come out with their fan boards produced by the Fenwal Corporation. I'll get into these features in detail when I get to that part of the video. So, Let's get to igniter board testing and a variety of igniter boards. Now that we see what's expected of an igniter board, let's explain a little bit about the tester. The IMT 12P tester is a battery-operated portable tester. It does not have to be plugged in for operation, but when you do have to recharge it, you plug in the adapter and charge the tester. You can test 75 to 100 boards with this tester before it has to be recharged. It comes with cables for attaching to the board, and it also comes with an adapter for the early fan control board that Dinosaur has had on the market for about 9 years. The tester has a power switch where you can turn on the tester or charge the battery if necessary. It has the flame sense switch, which in the down position allows you to sense the flame in the remote or external flame sense conditions. In the up position, it tests for local flame sense. To connect this tester to a board, you simply install the main cable, which is polarized so that you cannot install it improperly, the high voltage wire for the spark, and you're ready to connect a board to the tester. As you can see by the variety of boards I have here, we're going to spend quite a bit of time learning how to operate this tester on the wide variety of circuit boards that are used in the industry. The first thing we're going to do is we're going to explain what not to do with this tester. Before we hook any boards to this tester, let me cover a category that I call the no-no boards. And I've got to get my specs on for this one because I can't see as well as I used to. This one is a Suburban board called a 230481 part number. The finger spacing on this board, and this is a very early board according to the date code, this came out the 4th week of 1976. This finger spacing is no longer available, fortunately. But the finger spacing does not match the cable connector. And if you try to plug it in, you're going to blow the fuse in the tester. That's one of my no-no boards. Another no-no board is, don't be hooking up a board that has obviously burned components. You're wasting your time. You probably won't damage the tester, but the board is a problem to begin with. No sense wasting time. Another category. If the board has obvious physical damage, like a busted transformer, don't waste your time. Another category. If you look at the board and the etch or circuitry on the back of the board is burned, don't waste your time. These two boards don't really fall into the category of no-no boards. What they are is two boards with exactly the same part number, 231741. The early version is a single try board, the later version is a 3-try board. So you have to know what you're testing before you say, oh, this one isn't trying 3 times, it must be bad. In going through the functions of the igniter boards and what's expected, we covered the fact that boards have remote sense, local sense, and external sense. Remote sense of the finger, usually labeled S1. Local sense through the high voltage tower, and usually that finger is not labeled, but in some cases it is. And finally, external sense through a wire that dangles out of the box. Whether the box is black, gray, white, makes no difference. These testers are all IMT 12Ps. I pointed out previously that these are battery-operated portable testers Test 75 to 100 boards before they have to be recharged. To operate the tester, you turn it on. First, of course, you connect the board to it, but you turn it on, you should get the power light. If the battery in the tester is run down and you turn on the tester, the low battery light comes on. In order to recharge the tester, you connect the charger to the tester, plug it into a wall outlet, turn the tester on, and charge the battery for 24 hours. From now until tomorrow morning, whatever, okay? This tester, which has been charged for 24 hours several times, okay, still has a low battery light. This needs a new battery. But under normal operating conditions, you use the tester without the charger connected, turn it on, run your tests. I've connected two identical part numbers to these testers. They are part number 230587, very common older board from the suburban furnaces. I want to illustrate how a tester can be misleading. I turn both of these testers on. We get the NC check lights. After a delay of about 15 seconds, and that varies anywhere from 13 to 18, whatever, okay? And may depend upon the amount of voltage that's applied to the particular board. Now what's going to happen, they go into ignition, I sense a flame in the remote position on both boards. Because of the way the tester is designed, for these boards, they're going to continue to ignite forever, or until the battery dies. Valves will stay open. They continue to ignite because I haven't suppressed the spark, which I can do by flipping to the local position. But you'll notice in these two windows that we see a spark in both cases, and you say, oh, the boards are apparently okay, so we'll suppress the spark, lose the sense, and in about 6 seconds, both of them will transfer back to the NC terminals, like so. Now here's what was misleading that you can't see hooked up like this. And this is a method you're going to want to use when you're testing circuit boards and you think, gee, maybe it has a weak spark. What we're going to do is, instead of clipping the high voltage leads to the terminal, we're going to set them off to the side a little bit